Tutorials and upcoming tutorials, I'll be explaining about all the previous year's GATE question papers with the solutions. Okay, so without wasting time, let us start with the videos. And here is your first questions. Your first question is, it was asked in 1987 for the 2 marks, and the question was like, if a comma b and c are the constants, this a b c are the constants, and which of the following is the linearly inequalities? So first we have to know that what do you mean by inequalities. Okay, inequalities means the equations which contains greater than and or less than. If exist with the equations, then that equation is called as the inequalities. So for the inequalities, it should be there. So come to the first options. Your first option is ax plus bcy is equal to 0. Here a, b, c are the constant, already they have told, but the x and y are the arbitrary variables. It is not a fixed variables, so this is called arbitrary variables. And the they have asked about the inequalities. So this equations does not have the greater than or less than symbols. So this is very easy to eliminate, and you can eliminate this option. This will not be your correct option. So coming to the next options, that is b options. Ax square plus cy is equal to 21. See here, it does not have the greater than or equal to, so this one also you can eliminate. And this x contains 2 power 2, so they have asked about the linear, and this is not a linear, this is a quadratic, so you can eliminate. This will not be your correct options. So coming to the next options, so your next option is a b x plus a square y greater than or equal to c. It contains the greater than, it means inequality condition is satisfied. Now we have to check for the linear, it is linear or not. So the here the x and y, the arbitrary variables, have the power 1, so both have the 1 degree. So this is a linear, so this is correct options for these questions. Now coming to the D options, it can be eliminated because the x and y both have the 1 degree, so this will form the degree of 2. So this is not a linear, so you can eliminate this. So your correct option will be the C. So coming to the next questions, this question was asked in 1987 for the 2 marks. A square matrix is a singular matrix whenever there are the 4 options. He is asking about, and you can say that a square matrix is a singular matrix. So first of all, you should know that what do you mean by the singular matrix. The matrix which has determinant value will be 0. That matrix is called as the singular matrix. They have given 4 options. Your first option is the rows are the linearly independent. So again, they are the new term, that is the linearly independent. What do you mean by that linearly independent? So I'll be explaining with an example. Suppose a matrix having 2 rows and 2 columns, and the element of the matrix is 1, 2, and 2, and this is 4. Suppose this is your matrix, and if you'll take the 2 comma from the second rows, then you'll be getting 1 2 1 2. Now both rows having the same element. Okay, so both are the linearly dependent. You can say that both rows are the dependent to each other, so this is called dependent. So here they are talking about the independent. When you can say that a matrix is a singular matrix. Okay, singular matrix means whose value is 0. So the first options can be eliminated easily, because if rows or the column of the square matrix are linearly dependent, then the determinant of the matrix becomes 0. But the option they have given independent, so these options can be eliminated. Now coming to the B options. The B option, they told about the independent, so this one also can be eliminated easily. Now coming to the C options, you can see here the rows are linearly dependent. They have told about the dependent, so it will be our correct options. Coming to the third questions. The third question is was asked in 1994 for the 2 marks, and the question is, if A and B are the real symmetric matrix of size n cross n, then which of the following are the true? So the First option is A dot A transpose is equal to the I. I stand for the identity matrix. I hope you guys are the familiar with identity matrix. The matrix whose all the diagonal element is 1 and except the diagonal element all the element will be 0. So that matrix is said to be identity matrix. Now the first will be eliminating option by options. So the first that we should know that what is the symmetric matrix. A matrix is said to be a symmetric matrix if the matrix A is equal to the transpose of itself, right? So this, if this condition is satisfied, then you can tell that A is the symmetric matrix. Now coming to the first options, we have to prove the right hand side with the help of the left hand side. So we'll be taking A transpose. If with the help of this, if we are able to determine the right hand side value, then this will be our correct options. So now if here A, we can eliminate A is equal to A transpose, right? Because already in the questions they have told about the matrix that it is a symmetric matrix. No, so this is A transpose will be A transpose whole square, right? So it will not be equal to the identity matrix. So I'm not able to determine the left right hand side, so this will not be our correct options. Now coming to the next options, that is A is equal to 8 A to the power minus 1s. So we'll take the left hand side. So your left hand side is A and A is equal to A transpose is right. Already they have told in the questions that is the real symmetric matrix. Now coming to the options, we can write that A to the power minus 1 can be written as this, right? So this is not always the case, you'll be getting this. Okay, so this condition also fails and we are not able to determine the way. So this will not be your correct option. Now coming to the option C, your option C is AB is equal to BA. When you can tell that AB is equal to BA? Already I have told you that AB AB and BA both are the different conditions, and this is not always the case you'll be getting equal. There are the some cases that you'll be getting equal. So if you'll replace A transpose and B to the B transpose, then you'll be getting the same things left hand side also and right hand side also. So this will not be your correct options. Now coming to the D options, you have AB, okay, AB to the whole power transpose, right? So I hope you guys are familiar with the transpose properties. If this is the case, then you can write this is equal to the B transpose and A transpose. If you want to separate both the matrix, so you can write this as this. So now B is the symmetric matrix, so it B transpose can be replaced with B, and if it is also symmetric matrix, this also can be replaced with A. So now with the help of the left hand side, we are able to determine the right hand side, which is our options in given in the options. So this will be your correct options, right? Now coming to the next questions, it was asked in 1985 for the 1 marks. So the question is the rank of the following n plus 1 cross n plus 1 cross matrix where A is the real number. So before moving to the questions, I'll be explaining how to determine the data rank of the any matrix. So there are the two ways that you can find out the determinant of the matrix. The first method is row echelon forms. You make the any matrix into the row echelon forms. After finding the row echelon forms, you can get the rank of the matrix. So what is that actually, how it works and how transform any matrix to the row echelon forms, I'll be explaining. So now what is the actually row echelon forms? The row echelon form is the form of the matrix whose first row contains zero number of zeros. Zero number of zero means, suppose this is our matrix and it contains 1 2 3. Suppose this is a 3 cross 3 matrix, okay, and this contains, in the first row there is no zero element, okay, and in the second row there will be one element will be zero. After that any element can be zero, and in the it must be first element must be the zero, and the second in the third row two element must be zero and others may be zero. Okay, so this, if this type of matrix you are getting, then this matrix is called a row equivalence matrix. So by transforming any matrix into the row equivalence matrix, you can determine the rank of the matrix. Now there are one more method that you can find out the rank of the matrix, that is the determinant method. I'll be explaining how this can be done with the help of the determinant. The main definitions of the rank is the maximum order of the determinant which is non-zero in a matrix or the sub-matrix of it. Okay, we have to check all the possibilities. Whatever the possibilities will be, you have to check. For example, suppose I have a 2 cross 2 matrix. So here there will be only four element, right? There will be only four element. There are only one possibilities you can find out, that is the 2 cross 2. But in the 3 cross 3 there will be 9 element, or in that element there will be the more possibilities. You'll be getting 2 cross 2 matrix. How? See, you'll be getting, this is a 2 cross 2, 2 cross 2 matrix, this is second 2 cross 2 matrix, and there will be the third 2 cross 2 matrix, and there will be fourth 2 cross 2 matrix, and one 3 cross 3 matrix. You are getting 5 matrix. So all the 4 matrix has to be checked whether, if any matrix giving the non-zero value of that order, then it is for sure that the that order will be your rank of the matrix. How? I'll be explaining with the help of an example. Suppose I have a matrix of 3 cross 3 and the element of the matrix is 4, 3, 13, 6, 3, 4, 2, 1 and 0. This is your 3 cross 3 matrix. So you will check first, what you have to check first, you have to check minimum order matrix. So the minimum order matrix will have 2 cross 2. So will go from lower to higher. Okay, first I'll check for 2 cross 2, then 3 cross 3, then 4 cross 4 if it is possible, then 5 cross 5 if it is there. So first I'll be checking 4 cross 4. Here the 2 cross 2 is, we are getting, this is the one possible matrix of 2 cross 2. So here you will be getting 4 into 3 is 12, and have to find out the determinant of that matrix. 4 into 3 12, minus 3 into 1 3, and getting non-zero value of that matrix. Definitely it will have the 2 rank of that matrix, of the whole matrix. Now it may be 3, but it is for sure 2 rank of that matrix is there. So now we'll be checking for the 3 cross 3. So the possibility of 3 cross 3 is this, and you find out the determinant of 3 cross 3. If you are getting the 0, then the rank of the matrix will be 3. If you are not getting 0, then the rank of the matrix will be 3. Okay, and there are one point to be note down, that if the matrix having the if the matrix having all the element as a 0, then the rank of the matrix will be 0. The minimum rank of the any non-zero matrix will be 1. So guys, coming to the questions, your question is having the n plus 1 cross n plus 1 cross matrix. So you can see that all the element of the all the row having the same element. See, in the first columns all the row having the same element, in the second column all the row having the same element, in the third column all the row having the same element, and so on. So they all are linearly dependent to each others. Okay, in that case, if all the rows are linearly dependent to each other, you know that the minimum rank of the any matrix, non-zero matrix, will be 1. So the 1 will be the correct option for this questions. So the correct option will be 1. So guys, coming to the next questions, the questions They have given, it was asked in 1996 for the 2 marks, and there are the two matrix, and the question is asking in the which conditions we can tell that these two matrix are commute each other under multiplications. First matrix is, this is your first matrix. Now you have another matrix, that element is 1a 0 and 0b. So he's telling under multiplications. So first you have to out the AB and BA. Okay, BA. They have told already they are commute under the multiplications. Means AB and BA both are the equal. Already they have told. In which condition you have to find out. In which condition they are commute under the multiplications. So if you try to find that A dot B, you will be getting A dot B, you'll be getting this matrix. And when you'll try to find out the BA, then you'll be getting, this is AB, and BA will be, okay. So these are their matrix. So if both are equal, then we can tell that A cos theta is equal to the A cos theta. This is correct, right? A cos theta is equal to A cos theta. Now B sin minus B sin theta is equal to minus A sin theta, we can tell, right? We can tell. And A sin theta is equal to B sin theta also, and B cos theta is equal to B cos theta also. So here when you'll compare this, so with these are the same, okay, but whenever you'll compare with these two element, so you'll be getting A is equal to B. A is equal to B. Now we check in which options A is equal to B is given. So already here no, here no, here no. This will be your correct options. Now moving to the next questions. Your next question is the find out the determinant of the matrix. And this question was asked in 1997 for the 1 marks, and it is a very easy question, so I think so. Guys, before moving towards, I'll tell you, I'll suggest you one thing: stop the videos and just try to solve these questions. So this is your this is your matrix, and we have to find out the determinant of that matrix. How will you do that? So in the above, in the given questions, you can see that this is a upper triangular matrix. You see, this is the upper triangular matrix, and I hope you all are familiar with what is the upper triangular matrix, what is the lower triangular matrix. The upper triangular matrix is the matrix whose all the element below the diagonal will be 0. That matrix is said to be upper triangular matrix, and the lower triangular matrix is a matrix whose all the element above the diagonal element will be 0. Okay, so that matrix is said to be a lower triangular matrix, and in the given questions it is a low upper triangular matrix. There was a one concept to find out the determinant of the lower triangular matrix and upper triangular matrix. Multiply the diagonal element. The determinant of the upper and the lower triangular matrix is equal to the product of the principal diagonal element. So the determinant of this matrix will be 6 into 2 into 4 into minus 1. How much will you get? 6 to the 12, and 12 to 12 4 the 48, and 48 1 ja minus 1 ja minus 48. This is your correct answers. So minus 48 will be your correct answers. So guys, I think for today's this much is enough, and for the from the next videos I'll be moving fast, and I'll be covering more number of the questions. So if you like the videos, then hit the like button and subscribe my channel to get the regular update. Thank you for watching my videos.